Welcome to class today. Today we're going to talk about the number system. We'll talk about various types of numbers, how to put them in sets, find the intersections and unions of those sets, and to draw them out using Venn diagrams. So the first thing we want to do is talk about the different types of numbers. Most of the numbers we use on a daily basis are what we call real numbers. And there are various types of real numbers. The most simple set of those is called the natural numbers. This would be the numbers 1, 2, 3, and so on. These are also referred to as our counting numbers. Okay. Then we add the 0, and we get what we call whole numbers. Okay. Now, you'll notice neither of those sets have any fractions in them. They also don't have any negative numbers in them. So the integers are going to add our negative numbers. Okay, and integers are often referred to as the set Z. Okay, natural numbers would be the set N. Okay, all right, rational numbers, which are often referred to as the set Q, this is going to be all of our fractions, okay, which makes them decimals. But we're going to be real specific in the fact that they can be written as terminating decimals. In other words, they have an end. So for example, 0.23. Okay, that could be written as 23 hundredths. So it's a fraction and it's a decimal that ends. Or it can be repeating decimals. So for instance, 0.2 repeating. That could be written as 2 ninths. Now we want to make sure we understand too that the rational numbers contain every integer. Because think about the number 2, that could be written as 2 over 1. Okay, so any fraction that we could ever come up with, okay, can be part of or is part of the rational numbers. Okay, now that leaves the irrationals. Now notice the irrationals is this box over here is not connected to the rest of them. The natural numbers are whole numbers. That's why they're inside it. The whole numbers are integers. The integers are rational numbers, and the rational numbers are real. The irrational numbers are real numbers, but they are not any of these other 4 things. So these are decimals that do not terminate. Nor do they repeat. So some examples of this would be, for instance, the number pi. Pi is 3.14, and it keeps going forever, but it never actually repeats itself. Another example would be like the square root of 2 or the square root of 7. Okay, any square root that is not a perfect square would be irrational. Okay, all right, so those are our types of numbers. Now just for information, this diagram that I have here in front of you is called a Venn diagram, where we use shapes to represent the various sets, and we can put one inside the other, or we can have them overlap if they have common values. And we often use Venn diagrams to represent sets of things, and we'll kind of do some examples of those here in a little bit. Okay, so what type of number are these? We're going to list every set that they would be included in. So 5, first of all, is a natural number. That makes it a whole number. That makes it a integer. And that makes it a rational number. And of course, all of these are real. Okay, now 6.4 is an ending, a terminating decimal. So this is rational, which makes it real. Now think about that. 6.4 is 6 4/10. So that's 6 2/5. So it can be written as a fraction. Okay, 2.3 repeating. This is also rational, which makes it real. Okay, 2.3 repeating would be 2 1/3. Okay, so that is a fraction. All right, and then we already noticed that pi is an example of an irrational number, but it is still real. Okay. All right, so here's how we write sets. This first set, we're going to read this as B such that B is a boy in pre-cal class. Okay, this is in set builder notation. Okay, that's what this form of a set is called. Okay, but that set would include every boy in pre-cal class. So let's say that John is in pre-cal class. I could say John is an element of the set. Okay, because John is contained in there. He is a student in pre-cal class. Okay, all right, example 2, this is in roster or list notation. And I just list everything in the set. Okay, now if I wanted to put this one in set builder, then I could use little x such that x is between 1 and 9, and x is an element of the natural numbers. And I could write this out and just say x is a natural number if you want. Okay, but that's roster notation. And then this last one again is a set builder. And this is, of course, an interval. If you might think about it on the number line, here's 10. If I want to go less than or equal to 10, I'm going to start here and I'm going to go this way. Okay, so this is set builder. But there's a third way to write sets, and that is in interval notation. Now to write interval notation, we're going to simply put the beginning and the end. So it's going to end at 10. But it keeps going forever to the left. So what's over here all the way to the left? This would be negative infinity. Now notice when you do it in interval notation, the smaller value goes on the left. The bigger number goes on the right, just like it does on the number line. And then we put brackets on the ends. Now, if I can get to the value, if it is included in the set, I put a square bracket. If I can't get there, like the infinity, I can never actually get to an infinity, I put a parentheses. And that would be interval notation. Okay, so let's do a little more practice with that. So here's some number lines. So this set here is going from -2 to 5. I'm including the -2, but I'm not including the 5. If I wanted to write this in set builder notation, I would say x such that x is between -2 and 5. Notice I put the underline on the less than with the -2 because it can equal it. Okay, on this one, I'm going from 10 forever to the right. I can't get to an infinity, but I am including the 10. So this would be in set builder, x greater than or equal to 10. Okay, so this is how we write sets. We can use interval notation, or we can use our inequalities like we've done in the past in set builder. Okay. All right, now here are some examples of those Venn diagrams. And so in this first set, the universal set is the juniors. Okay, all juniors. So I would actually write that as X, such that X is a junior. Okay, now within there I have the set of boys and I have the set of girls. Now notice they do not overlap at all. Okay, so there's nothing in common. So here this symbol means intersection. Now an intersection is a conjunction, which means they have to be true at the same time, and we would use the word and. So are there any juniors that are boys and also girls at the same time? Well, there are not. There's no overlap. So I would say this is the empty set, or I could write it like this. Okay? Now this symbol is the union of. So it's going to end up being the set that X is a boy or a girl in my universal set. Okay, so in reality, this is all juniors. I've taken all the boys and all the girls and I put them together. Okay, all right, now in this one, our universal set is high school boys. Okay, now again, these are ands. These are intersections. So I need to know where they overlap. I need students that are football, track, and basketball. So that's this little overlap right here. That would be in all three circles. So this is the set that X is a high school boy that plays all three sports. Okay. Now, if I want to do the union, these are or statements. So that would include all the football, all the basketball, and all the track. So this is the set of high school boys that play any of the three sports. So the only thing that wouldn't be in that set were the boys that didn't play any, okay? Or a boy that just played golf, because it's not in the diagram, okay? All right, now let's get to some examples with numbers. You know, we are in math class, we want to deal with numbers. Okay, so again, this is an intersection. So I want to find A and B. So I need the numbers that are in both sets. So this would simply be 3 and 4. If I want the union, if I want to do A or B, now I'm going to take all of A and all of B, and I'm going to list all of those. So 1, 2, 3, 4, 5, and 6. So unions just take everything from both sets and put them together. Now I do not have to repeat. The 3 and the 4 are in both sets. I don't have to list them twice. Okay? A intersects C. Notice A and C have no intersection. So this is the empty set. There's nothing in common. Okay? All right, if I want to join This is an or statement, A and C. If I want to take A or C, that means I'm going to list everything in A and I'm going to list everything in C. And I'm going to put them together. Okay? Now this last one, this little tick mark here means not A. So I'm going to list everything that's not in A. So that means I'm going to list the 5, the 6, the 7, and the 8. This is called the complement of A. All right? Okay, so that gets us a little bit of an introduction to sets and Venn diagrams. So what you can do now is try these couple of problems to see if you can follow what we did. This will be our exit ticket for tomorrow if you're in class. So have a good day and we'll see you next time.